Students, today we are going to exercise 1.1 from real numbers. First question, express each number as a product of its prime factors. It is given, first one is 140. 140 we can divide by 2, 70 times it goes. Again we can divide by 2, 35, 5, 7 times. So 140 is equal to 2 square into 5 into 7. Second question is given 156. We can divide by 2. We are getting here 78 times it goes. Divide by 2, it goes 39 times. We can divide by 3, 1 13s are 13 one time. So 156 is equal to 2 square into 3 into 13. Next question is given 3825. We can divide by 3. It goes 1275. Again we can divide by 3, 425 times it goes. Again we can divide by 5, it goes 85 times. So we can divide by 5, it goes 17 times. So 3825 is equal to 3 square into 5 square into 17. Next one is given 5005. Divide by 5, you will get here 1001. You can divide this one again by 7. We can divide. It goes 143 times. Then we can divide by 11. It goes 13 times. So it is 5005 is equal to 5 into 7 into 11 into 13. Next one is given here 7429. We can divide this number by 17. We are getting 437 times here. Again we can divide this number by 19. It goes 23 times. So 7429 is equal to 17 into 19 into 23. Now we are going to the second sum. Find the LCM and HCF of the following pairs of integers and verify LCM into HCF is equal to product of the two numbers. First question is given 26 and 91. So we have to factorize here 26. If we divide by 2, we will get 13. So we can write 2 into 13. Then we have 91. We can divide by 7. It goes 13 times. So 91 is equal to 7 into 13. Now the LCM of 26 and 91 is equal to, you should write all the factors first, 2 into 7 into 13. And all are having here highest power is 1 itself. So when you multiply everything, you will get 182. Now the HCF of 26 and 91 is equal to, here we should go for the common one, in that the lowest power we have here 13. So that is the LCM. Now for the verification, we want to multiply LCM into HCF we want to multiply. That is 182 into 13. When you multiply this, you will get here 2366. And product of the numbers when you multiply, that is, we should multiply 26 into 91 and you will get here 2366. So what we can understand, LCM into HCF is equal to product of the numbers. Now we are going to the second sum of this. 510 and 92. 510, if you prime factorize by 2, it goes here 255 times. Again we can divide this by 3. we will get 85 times, and it is divisible by 5 and 17. So we are getting here 510 is equal to 2 into 3 into 5 into 17. 92 if we divide by 2, we are getting here 46 times. 2 goes 23 times. So 23 is a prime number. So 92 is equal to 2 square into 23. Now we'll find the LCM of this. 510 and 92 is equal to, we'll write all the factors. 2 is there, 3, 5, 17 and 23, and all the highest power here, highest power is 2, remaining all are 1. When we simplify this, we are getting 23,460. Now we'll find the HCF of the numbers. That is out of common factor, which is having the lowest power, that is 2. Now we want to find out LCM into HCF. That is 23,460. We want to multiply by 2, so that we are getting here 46,920. Then we want to find the product of the numbers. That is 510 into 92, and when you multiply this, you will get 46,920. Therefore, LCM into HCF is equal to product of the numbers. The third sum, it is given 336 and 54. We'll factorize 336. It goes by 2, 168 times, 284 times, 242 times, 221, and 3 goes 7 times. So we can write here 336 is equal to 2 to the power of 4 into 3 into 7. Next one will come is 54. We can divide by 2. It goes 27 times. 3 9s are 3 3s are. So we can get here 54 is equal to 2 into 3 cube. Now the LCM of 336 and 54 is equal to, here write all the factors, 2 into 3 into 7. Write all the highest powers. 3 here, this is 1, and when you simplify all this, you will get here 3024. Next we are going to HCF of 336, 54 is equal to, here out of common we'll write the lower power, that is 2, and here it is 3, so HCF is 6. Now we'll multiply LCM into HCF for the verification, that is 3024 into 6. When we multiply this, we are getting here 18,144. Now we'll find the product of the numbers. That is 336 into 54. When we multiply this, again we'll get 18,144. So we can understand LCM into HCF is equal to product of the numbers. Now we are coming to the third sum. Find the LCM and HCF of the following integers by applying prime factorization method. And here first sum is given here, 12, 15 and 21. So 12, if we factorize, 2 6 times, 2 3 times. So 12 is equal to 2 square into 3. 15, it goes 3 5 times. So 15 is equal to 3 into 5 and 21 goes by 3 7 times. So 21 is equal to 3 into 7. So LCM of this is, write all the factors. 2 is there, 3, 5 and 7. Highest power for 2 is 2 square. 3 is highest power is 1. This is 5 and 7 is also 1. When you simplify all this, you will get here 420. That is the LCM of this. Then HCF, we have to find the common factor out of that lowest power, and we have here 3. Into the second sum, 17, 23 and 29. Here's prime factorization of 17 is 17 itself because it is a prime number. 23 is also 23 only, and 29 is a prime number, it is 29. So here LCM is all the factors we want to write, 17 into 23 into 29, and multiply all this, then you will get here it is 11,339. Now what is the HCF of this? HCF is, there is no common factor here, we can't see that anything. So but here everywhere 1 is the factor of this, so HCF is 1. So any 2 or more than 2 numbers are prime, then always HCF is 1 and the LCM is the product of all that numbers. We are going to the third sum in this. 8, 9 and 25. 8 is 2 cube, 9 is 3 square and 25 is 5 square. Now LCM is, writing all the factors, 2 into 3 into 5 and all the highest factors, 3 here, 2 and 5 square, highest powers we wrote. So simplifying everything, we are getting here 1800. Now what is the HCF of this? HCF, we don't have anything common here, but 1 is the factor of everything, so HCF is 1. And in this case, one more note you should do it. This 8, 9 and 25, these all the numbers are not prime numbers, but these are co-primes because there is no common factor for all this other than 1. Such numbers are known as co-prime numbers. So HCF of co-prime numbers is also equal to 1. Going to fourth sum. This is one very important question for your board exam. Based on this, some other questions can come. It is given here, given that HCF of 306,657 is equal to 9. Find the LCM of 306,657. Okay, now we have the formula here. HCF of A, B into LCM of A, B is equal to A into B. It is for any two positive integers. Okay, here it is. Now we can write here. Here A is 306 and B is 657. So HCF of 306,657 into LCM of 306,657 is equal to 306 into 657. So here HCF is given 9. I will substitute. We want to find out LCM of 306,657 is equal to 306 into 657. So we are getting LCM of 306,657 is equal to 306 into 657 divided by 9. So we can simplify this. 9 can be cancelled, even both the numbers, because that is HCF. When we simplify this, you will get 22,338. We are going to the next sum. Check whether 6 to the power of n can end with the digit 0 for any natural number n. First of all, I want to explain to you what is the meaning of the question. 6 to the power of n, they are saying n is a natural number. You know that natural number is 1, 2, 3, 4. So dash dash dash. So 6 to the power of 1 if we take, we are getting 6. 6 to the power of 2, we are getting 36. 6 to the power of 3, 216. Like this it continues. Now they are saying when we write like this, is there any chance last digit will come 0? Now to have any number last digit is 0, it should have 2 and 5 both are the factors. For example, you see here 2 into 5 into 17 is there. 2 into 5 10, 10 into 17 170, last digit came 0. 2 into 5 is there here into 12. 12 into 10 it is 120, last digit came 0. So here we'll see now what will happen. 6 to the power of n. I'll find the prime factorization of 6. That is 2 into 3 to the power of n. So we can write 2 to the power of n into 3 to the power of n we can write. So here we can see only 2 is the factor. 5 is the factor is not there. So any number end with the digit 0 must have 2 and 5 both as the factors. And 6 to the power of n is having only 2 and 3 are the factors. And whatever uniqueness of fundamental theorem of arithmetic says, there is no other primes other than this 2 and 3 for this number. So there is no natural number n for which 6 to the power of n ends with the digit 0. Next we are going to the question. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Here the first one is given 7 into 11 into 13 plus 13. We can write 13 common outside. We are getting 7 into 11 plus 1. So we will get 13 into 77 plus 1 is 78. So here there are two factors 13 and 78 other than 1 and itself. So since there are more than two factors, it is a composite number. Now we are going to the second sum in that. 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. We can write 5 common outside. We are getting 7 into 6 into 4 into 3 into 2 into 1 plus 1. So we will get 5 into 1008 when we multiply all this plus 1. So 5 into 1009. So here there are two factors 5 and 1009 other than 1 and itself. Therefore, since there are more than two factors, it is a composite number. Now we are going to the last sum of this exercise. There is a circular path around sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose both start at the same point, at the same time, and go in the same direction. After how many minutes will they meet again at the starting point? The sum says like this. Here there is a circular path. Maybe it is in take one point here. Here Ravi and Sonia are there. Sonia is taking 18 minutes to complete one full round and Ravi takes 12 minutes. That means Ravi is faster. When Ravi completes one round, Sonia will be there on the way. Now we can try to understand how to do this sum. Ravi and Sonia. First round, Ravi will complete in 12 minutes. Sonia will complete in 18 minutes. Second round, Ravi will complete in 24 minutes and Sonia will complete in 36 minutes. Third round, Ravi will complete in 36 minutes and Sonia will complete in 54 minutes. So what we can understand here, in 36 minutes, they will be there here again together in the starting point. And this is the LCM of these two numbers. So here, time taken by Ravi to complete one round is 12 minutes and time taken by Sonia to complete one round is 18 minutes. They will meet again in LCM of 18, 12 minutes. Okay, so here we'll find out the LCM of 18 and 12. 18, if we factorize 2 9 times, 3 3s are, so we can get here 18 is equal to 2 into 3 square, 12, 2 6 times, 2 3 times. So we are getting here 12 is equal to 2 square into 3. So LCM of 18, 12 is equal to 2 square into 3 square. So that is 4 into 9, 36. So they will meet again in 36 minutes. Therefore, they will meet again